So we will keep focusing on this unit circle representation of the trig functions. And the most important fact here is that on the unit circle, this x-coordinate is cosine of the angle theta in standard position. The y-coordinate is sine of theta. Now let's explore some of the implications of this. And one thing we have not talked about at all yet in here are what are called the quadrantal angles. These are angles that have terminal sides on the coordinate axes. And an example of a quadrantal angle is actually 0 degrees. So 0 degrees would be an angle that just is initial and terminal side right on the positive x-axis. We can now define 0 degrees is also 0 radians. We can define the sine and cosine of 0 degrees. Now the sine of 0 degrees will be the y-coordinate of the point of intersection of the terminal side with the unit circle. That y-coordinate is 0. And the cosine of 0 degrees will be the x-coordinate of this terminal side, so that's 1. So it's kind of surprising. Cosine of 0 is 1. Okay? Sine of 0 is 0, but cosine of 0 is 1. And then tangent, we can always get tangent by taking sine over cosine. So 0 over 1 is 0. Tangent of 0 degrees is 0. Now let's next look at 90 degrees, which is pi over 2 radians. To define sine and cosine, again, we're going to rely on the unit circle. And the terminal side of 90 degrees is the positive y-axis. The y-coordinate, where the unit circle touches the positive y-axis, is 1. So sine of pi over 2 is 1. But cosine of pi over 2, we say is 0, because the x-coordinate of this point on the y-axis, this y-axis intercept, is 0. And now when we try to compute tangent, we're taking sine over cosine, right? We're trying to take 1 over 0, but you can't divide by 0. So we say that the tangent of 90 degrees is undefined. Next, let's look at 180 degrees. 180 degrees has a terminal side along the negative x-axis. The y-coordinate of the point of intersection with the unit circle is 0. So sine of 180 degrees is 0. And I forgot to write the radian measure of 180 degrees is pi here. Cosine of 180 degrees is negative 1. We're going to say it's the x-coordinate of this point of intersection, negative 1. And tangent of 180 degrees, well, that's sine over cosine, 0 over negative 1. And that's perfectly okay. That's equal to 0. That does have a value. 270 degrees is 3/4 of the way around the unit circle. Now, to get the radian measure for 270, just think in terms of multiples of 90 degrees. It's 3 times 90. So it's 3 times pi over 2, right? 3 times pi over 2 is 3 pi over 2. Or think 1 pi over 2, 2 pi over 2 is 180, 3 pi over 2 is 270. And the sine of 270 will be the y-coordinate of the point of intersection on the unit circle. That's negative 1. We say sine of 270 degrees is negative 1. But the cosine, which is the x-coordinate, is 0. Tangent would be negative 1 over 0 if we could calculate that, but we can't. We can't divide by 0. So the tangent of 270 is also undefined. And we can keep going. We can go full circle to 360 all the way around. But 360 is coterminal with 0 degrees. So the sine and cosine are going to match up with 0 degrees. And so let's just see, radian measure of 360 is 2 pi. The sine of 360 is the same as the sine of 0, so that's 0. Cosine of 360 is the same as cosine 0 is 1. The tangent is going to be 0 over 1, which is 0, perfectly well defined. And I'm just going to say, etc. We can keep going around and around and around. And there's also negative quadrantal angles also. Just a couple comments here. There are no reference angles for the quadrantal angles. And we don't need them because reference angles are meant to help us calculate values of sine and cosine. We can get the values of sine and cosine so easily from the x-axis and y-axis intercepts with the unit circle. And so memorize the sine, cosine, and tangent values for quadrantal angles. Now, you know, it's so easy to go back to this unit circle picture. I'm not sure what it means to even memorize them because it should be very easy for you to remember the intercepts on the unit circle. And so you can always just refer back to this picture in your mind, right, to come up with these values. So let's do now exercise this up a bit. I guess this is exercise 10 from this section. Determine each value. And so for part A here, we want to find sine of negative 90 degrees. Sine of negative 90 degrees. Well, I can quickly draw a unit circle picture. Negative 90 degrees in standard position is like so. I know it intersects the unit circle at 0, negative 1. And the sine will be the y-coordinate of that point of intersection. So sine of negative 90 degrees is negative 1. It's that easy. Part B, what's the cosine of 3 pi? Cosine of 3 pi, let's draw another picture. So let's see, in standard position we got pi, 2 pi, 3 pi. 3 pi goes 1.5 times around the unit circle. It ends up here at the point negative 1, 0. And it's got the same terminal side as 180 degrees. The cosine of 3 pi is the x-coordinate of this point, so it's negative 1. Negative 1 also. And one more here. Let's do tangent of 5 pi over 2. Tangent of 5 pi over 2. And let's imagine where the terminal side of 5 pi over 2 is. I'm going to think of that as 5 times pi over 2. So 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2 is it's going to have the same terminal side as pi over 2. This is the point 0, 1 on the unit circle. So now tangent of 5 pi over 2, just calculate sine of 5 pi over 2 over cosine of 5 pi over 2. Don't memorize tangent values separately. The sine of 5 pi over 2 is the y-coordinate, 1. The cosine is the x-coordinate there, 0. 1 over 0 is undefined, so you got to write this word. The tangent of 5 pi over 2 is undefined. And so that's quadrantal angles, which we will work with a lot from now on.